For question number 1 on test number 3, we have the construction of an equilateral triangle. And the way that we construct an equilateral triangle is by copying the length of a side 3 times. For example, let me get my compass out. In order to do this construction, you would measure the length of a line segment, and you would use that one length to construct the other 2 sides of the triangle. So since everything is constructed using the same line segment, all of the sides are congruent or equal in measurement to each other. Remember, congruent means exactly the same shape and size. So equal and congruent pretty much mean the same thing, except equal is talking about numbers and congruent is talking about the line segments themselves being the same as each other. Number 2. So here we have a couple of triangles in our diagram. I'm going to start with triangle DBC because we already know 2 angles of that triangle. We know the 18-degree angle and the 24-degree angle. And if we add those together, we get 42 degrees. I'm going to subtract that from 180 degrees because all 3 angles of any triangle always make 180 degrees. And when I add it up and subtract it from 180, I get 138 degrees. Now these 2 angles are supplementary. Together they form a straight angle. So I'm going to do 180 minus 138. And I get 42 degrees. Now in this triangle DAB, I now know 2 angles. So I'm going to add them up, 66 plus 42, and I got 108. And I'm going to subtract that from 180 because all 3 angles of any triangle always add to 180 degrees. So now the triangle we're focusing on in the question is triangle ABD, and the longest side is going to be opposite from the biggest angle. So here's the biggest angle. So we have found the biggest side. Moving on over here, we have given information. Let's mark it in our diagram. Line FAD is parallel to line EHC. That's a big one. It's very important. And the reason why it's important is because now, let me highlight that a bit better. Now if I highlight my parallel lines and my transversal, we'll see that letter Z. So we actually do have congruent alternate interior angles here in the corner of the Z. And that's something that will definitely help us out a little bit later on. So whenever you have parallel lines, they're not there for no reason. They're there for you to draw a conclusion about angle relationships. And oftentimes it's either alternate interior angles or corresponding angles. Those are the big ones. FAB is 48 degrees. And if that's 48 degrees, its alternate interior angle here is also 48 degrees. And we know that ECB is 18 degrees. And we need to find the measurement of ABC, which is this angle here. So first, in this triangle HCB, I know 2 angles, the 48 degrees and the 18-degree angle. So I'm going to add those up, 48 plus 18, and I got 66, and I'm going to subtract that from 180 because all 3 angles of any triangle always make 180. So this angle over here, HBC, the last angle of this triangle, would be 114 degrees. Now, this angle is supplementary with the one next to it with angle ABC. So I'm going to do 180 degrees minus 114 to get this angle. And that's 66 degrees. This is an altitude. It's a construction of a perpendicular line to the side of a triangle that passes through the opposite vertex. And by definition, that is an altitude. We can actually eliminate all of the other ones because all the other ones have to do with bisecting or midpoints. And from this construction, even though we don't trust diagrams, it's clearly, without a doubt in my mind, not cutting side AB in half, not passing through the midpoint. Okay, over here, let's mark our diagram. We're given that DM is congruent to EL, and we need to prove that DL is congruent to EM. I'm just going to mark those in green right now, what we're proving. So we're starting with the blue and the red segments, and we're trying to get the green segments. So we're going smaller here. So this is going to be subtraction. So right away, I'm going to knock out answer choice 1 and 3. Now I'm between 2 and 4. So let me write out my subtraction. I have DM, that's the blue segment, and my goal is to make DL, the green segment. To go from DM to DL, I need to get rid of this part. DM, take away this part, leaves me over with DL. So I need to get rid of LM. I'm also starting with EL, and I need to make EM. So to get from EL to EM, the green piece, I once again need to get rid of this part, because if I have the red segment and I get rid of this part, I'm left over with just this part, which is what I need. So I'm starting with congruent segments, and I'm subtracting LM from both of these congruent segments. LM is congruent to itself because it's the same segment. So if I was doing the subtraction in a proof, I would need to first state that LM is congruent to itself by reflexive property in order for the subtraction to be valid. Okay, here we need to write the equation of the perpendicular bisector of a line segment having endpoints 1, 2, 3, -1, and 3, 1, 2, 3, 1, 2, 3, 4, 5. So automatically, I see that this is a vertical line. So I already know that the perpendicular bisector is going to be a horizontal line because horizontal lines and vertical lines create 90-degree angles when they intersect. So I already know it's going to have a zero slope without even doing anything because a vertical line has an undefined slope with 0 in the denominator. And if you flip it over, 0 will be in the top, and 0 divided by anything is just 0. So I already know the slope is going to be 0, but I will write out the slope for you guys. And this one's pretty easy to find the midpoint as well. The midpoint is 1, 2, 3, 1, 2. So I could write my equation of the line with the midpoint and with the slope without even doing any work. But we do need to show work, so I'm going to show it. I'm going to find the slope of the original line segment. So that's y2 minus y1. A lot of people were mixing up the x's and the y's. If that confuses you, label x1, y1, x2, y2. Label your points so you don't mix and match the x and the y coordinates. Slope is y2 minus y1, and then the x is in the bottom. x2 minus x1. And there's a 0 in the denominator. If you do 6 divided by 0 in your calculator, that is an error. It's an undefined slope. But that's okay. We're going to find the opposite reciprocal of it because we need the slope of the perpendicular line. And if I flip this over and I make it negative, that's negative 0 over 6. And if you type that one into your calculator, well, that's just 0 because 0 divided by anything is 0. And you can always test it on your calculator to verify. And I can see my midpoint of the line segment since it's a straight line from the graph. But if you can't, we can do the midpoint formula with the 2 points. So that would be the average of the x coordinates, comma the average of the y coordinates. And that's because a perpendicular bisectors pass through midpoints. So that's why we need the line to go through the midpoint. So that's 3, 2. Now we just need to write the equation of the line. I'm going to use point slope form. And point slope form is super simple because we just need to plug in the y coordinate, the slope, and the x coordinate. And there we go. If you solve it out for y, this is equivalent to the line y equals 2. It's just two different ways of writing the same thing. You did not have to solve it. And if we graph this, zero slope is a horizontal line going right through the point 3, 2. There's our perpendicular bisector. Okay, I don't know if you guys know this, but this question was straight from review sheet number 2. If you pull out review sheet for test 2, this one was on it. So this was actually one that you already completed and studied in the past. So given that angle 1 is congruent to angle 3, remember to always mark your diagram. And we're given that CE bisects angle DCB. So angle DCB is this angle over here. So since it's being bisected, the two equal parts would be angle 3 and angle 4. So I'm just going to mark that in the same color so it's easier to see. Our ultimate goal is to prove CE and AB are parallel to each other. And when we prove parallel, an angle relationship has to be used to prove that. Usually, it's either alternate interior angles being congruent or corresponding angles being congruent. So we're going to see which one we have the information for here. So let me put my givens. And you can either break your givens up or you can put them in the same step. Since this was a fill-in-the-blank proof and there was only one spot for givens, you do need to have both. Oops, I'm writing the proof statement. You do need to have both of your givens here. On the Regents exam, if you don't write your givens, or all of them, you will lose points. You don't get any points for writing the givens, but you do lose points if you don't have them, because the givens are your starting point, and it's the basis for all your other conclusions that you're drawing. Okay, so we have angle 4 congruent to angle 3 in our diagram, and that was from the angle being bisected. An angle bisector splits an angle into two congruent parts. As said in class many times, I am not taking angle bisector alone or definition of angle bisector, write it out. I did take points off for that. Not full credit, but I took off half a point for that. So now we have to draw a conclusion using transitive property. Since I color coded, I can kind of see it already in my diagram. I see that angle 3 has both a blue and a red marking on it. So angle 1 and angle 4 are both congruent to angle 3. So that means angle 1 and angle 4 have to be congruent to each other. And that's why I highly recommend marking the diagram because it makes your conclusions a lot easier to see, especially if you color code. Now, you can also tell that from what you previously proved in the proof, because in the proof, in your givens, you had angle 1 congruent to angle 3. And then in step 2, we had angle 4 congruent to angle 3. So angle 1 and angle 4 were both congruent to angle 3. So that means that they have to be congruent to each other by the transitive property. If two things are congruent to the same third thing, then they have to be congruent to each other. And when you're writing a proof, generally, the statement below is going to follow from what you proved above. So we just proved something about angle 1 and angle 4. So I'm thinking that that's going to be the key for showing the lines are parallel. Now, even though a lot of you guys wanted to use alternate interior angles, we actually don't have that information here. And let me backtrack and show you why. So here's a Z, but we don't know anything about angle 2, the other angle in the corner of the Z. Or if we go this way, We don't know anything about this angle in the corner of the Z. So alternate interior angles is not going to work here, although it's really nice when it does. So let me once again circle angle 1 and angle 4. And let me just highlight those. And I'm just going to extend a bit here so that you could see that they're corresponding angles. We have top right, we have top right. We have corresponding angles. And kind of looks like a letter F. Letter F means corresponding angles. I don't really like that one because I don't feel like it really does look like a letter F. So I just like to extend a little bit. So top right and top right. So I'm going to write that here. If corresponding angles are congruent, lines cut by a transversal are parallel. Okay, moving along over here. So we have P, 1, 2, 3, -1. We have Q, 1, 2, 3, 4, 5, 6, 7. And we have R. And it says points A and B are midpoints of PQ and RQ. So notice that there are no points A and B. We have to actually find those points. A is the midpoint of PQ, and B is the midpoint of RQ. So we need to find those. So the midpoint of PQ, I'm going to do that first. Let me just do that over here off to the side. I'll say point A. Midpoint of PQ is -3 plus -1 over 2, -1 plus 7 over 2. And that is -2, comma 3. And now for point B, that's the midpoint of RQ. So for RQ, that would be -1 plus 3 over 2, 7 plus 3 over 2. So that would be 1, 5. That's a negative. Sorry about that. Okay, so now we have points A and B. So what we need to do first is prove AB is parallel to PR. Parallel lines have the same slopes. So slope formula is the formula that we need to use. That's y2 minus y1 over x2 minus x1. So I'm going to find the slope of PR first. All right, slope of PR. And the slope of PR would be y2 minus y1 over x2 minus x1. So that is 4 over 6, which reduces to 2 over 3. Now I'm going to find the slope of AB so I can compare them. And we just found points A and B. So that is y2 minus y1 over x2 minus x1, which is also 2 over 3, which is what I wanted to happen because I'm proving that they're parallel. And guys, if they give you something to prove, it's always going to be true. They're not going to have you prove something false. It is true. That's what you can expect to happen. So concluding statement, since AB and PR have equal slopes, they are parallel. Okay, then over here we need to prove that PR is half the length of AB. Whenever we're finding lengths, that's going to be distance formula. So let's do our distances. First I'm going to do PR, and that should be AB is half the length of PR. That was a typo because AB is going to be smaller. So PR So that would be x2 minus x1 squared plus y2 minus y1 squared. So that is 36 plus 16, which is radical 52. Okay, now we're going to find the length of AB using the distance formula, using the points that we found previously. So that would be x2 minus x1 squared plus y2 minus y1 squared. So that would be 9 plus 4, and that's radical 13. So even if you aren't sure how these are related, you know that AB is supposed to be half the length of PR. So put into your calculator. Put in radical 52 divided by radical 13. And you will get 2. They are double each other. But even if you weren't sure about that, you can still write your concluding statement because you know what the goal is supposed to be. You know your distances are supposed to show that one is half the length of the other. Since, let me word this differently. Since radical 13 is half of radical 52, AB is half the length of PR. Okay, this one over here, we have medians. Medians connect midpoint to opposite vertex. And the big thing about medians is that they meet to form the centroid. And the centroid splits each of the medians in a 2-to-1 ratio. So if CE is 5, CE is the shorter part of this median. So that's the 1 part of the ratio. So the 2 part of the ratio would have to be 10. YF, that's this whole median here is 21. So there's the 2 part and the 1 part of that median. And together, it makes 21. So the shorter part is 7. And the longer part, if you double it, would be 14. So that's 7 right here. And then finally, we know that XZ, the side of the triangle, is 15. While the medians are what's happening inside the triangle. But remember, median connects midpoint to opposite vertex. So F, E, and D are midpoints of the sides of the triangles that they're on. So they're splitting the side of the triangle in half. So that's 7.5. So we can add them together because our goal is to find the perimeter of this triangle. And now we know the 3 sides. So that's 14.5 plus 10, that's 24.5. Okay, over here, we're constructing the 2 perpendicular bisectors. Well, 2 perpendicular bisectors of the sides of the triangle. And the point where they meet is called the centroid. Sorry, it's called the circumcenter. I'm losing my mind today. The medians meet to form the centroid. I have it in my mind from the last question. But perpendicular bisectors alone by themselves meet to form the circumcenter. And in this video, I'm not going to do the orthocenter construction. You can watch my weekly recap video where I go through it. In my weekly recap video called All Constructions, it goes through all of the constructions that we've learned so far. So this point right over here, where they intersect, is the point that they wanted you to label P. And once again, that is called the circumcenter. Actually, you know what? I'll do the orthocenter really quickly in this video. It's not going to take too much longer. Okay, so orthocenter is where the altitudes meet. Altitude goes from, is a perpendicular line through the opposite vertex. So I'm going to do to the side first. So I'm going to put my compass on the point I wanted to pass through, which is the opposite vertex. This is basically the perpendicular line through a point construction. And all I want to do is make an arc. And what my arc needs to do is it needs to intersect the side of the triangle in two spots. Just trying to get a good distance for that. No, it needs to be a little bit bigger. Sometimes it takes a little bit of trial and error here. There we go. So we have one intersection point and another intersection point where it intersects the side of the triangle. And then all I need to do is put my compass on each one of those intersection points. The exact distance does not matter. And right through those intersection points, we're going to make our altitude that goes through the opposite vertex. And this is an equilateral triangle. Well, it's an acute triangle, so it's going to look like it cuts the sides in half. But an altitude doesn't have to cut the sides of the triangle in half. So I just want to point that out. Okay, so now I'm going to do to the side. So I'm going to put my compass on the opposite vertex, which would be right here. And let me just get a different color on this. Now it needs to be a little bit bigger than that. This is super hard to do on the computer. It's so much easier to do this on paper. Okay, so now I have my 2 points where it intersects the side of the triangle. So I'm going to go over to 1, put an arc, and then using the same measurement as best as I can, I'm going to match it up to that point and make the same arc. Oops. This is going everywhere. Okay, right through those intersection points, I'm going to draw my altitude to the opposite vertex, and there's my orthocenter.